Am I audible?
Sir, your voice is lagging a lot. I can't understand anything.
My wait. Am I audible? Am I audible clearly now?
Yes, sir, just a little bit, but it's better.
Okay. So in the previous class, you have seen that we covered up to nomenclature, right?
Sir, I can't understand.
Can you hear me properly?
Yes, sir, now I can.
Okay, let me know when the voice is lagging because today's my Wi-Fi is not working well.
Okay, sir.
So today we are gonna start a structure of alcohol and phenols. A structure of functional groups. So you can see we are going to start basically a structure of functional group. So we just took an example of alcohol, that is methanol, and methanol has a structure like this: hydrogen, hydrogen, and hydrogen. And oxygen has two lone pair. That's why there will be repulsion, and the angle between these two will be 108.9 degree. And again, when we are going to talk about phenol, you can see this angle will be 109 degree. And again, when we are going to talk about ether, that means basically methoxy, methane. So its the structure will be like this, and the angle between COC is 111.7. So this is the structure of all the three functional groups, in which you can see methanol has the most a smallest angle, because the repulsion here is larger than here and here. That's why the angle between COH in methanol is very less. Please write it. Nadia, we just started the lecture. Please let me know when you are done with this. Then we will start preparation of alcohols. Aman, are you done with this?
Yes, sir, I just finished.
Madiha, okay, you both of you. Now we are going to start preparation of alcohols. Preparation of alcohols. So there are many ways to prepare alcohol, and we will study some of them. And the first is basically from alkenes. From alkenes. How we are gonna prepare alcohol from alkenes? So in this, we have the first method, that is by acid catalyzed catalyzed hydration. By acid catalyzed hydration. Hydration, you know, the hydration means basically addition of water in the presence of acid. That is called acid catalyzed hydration. And it's very easy. When alkene react with water, I can write an alkene react with water in the presence of acid as catalyst. In the presence of acid as catalyst, then alcohols form. Then alcohols form. First, right up to this, then I will explain the reaction and also the mechanism. So the important point is that when you are going to react an alkene with water in the presence of acid, that acid will act as catalyst. Then alcohol is formed. As you can see, if you have an alkene, that means C and C, bond between C and C is double, and you are going to react this with H2O in the presence of acid as a catalyst. What will happen? One of the bond will break and the older bond will be the same. And now H2O has two parts, H plus and OH minus. This will be distributed according to the situation. Please get up to this. Let me know when you are done with this. Are you done with this?
No, sir.
Okay. Please let me know when you are done with this. Very good, Madina.
Yes, sir. Done.
Now see, I'm going to give you a question. Please do it carefully. I just gave you propene and we added water in propene in the presence of acid. Please let me know the product. When I say product, that means the major product.
So it will be CH3, CH, then H attached, and then CH2 with OH.
And I mean, isn't it possible that if I'm going to write OH here and then CH2H, that means CH3? This possibility is also there.
Yes, sir.
Now you have to decide whether which one of the following, which one of them is major and minor. Can you tell me which one is major and which one is minor?
The major product.
This will be the major and this is minor because symmetry is more here, that's why. Is that clear?
Yes, sir.
So you are going to write this product, not this product. Basically, it is like Markovnikov in the previous chapter. Have you heard of it? In the previous chapter, you have heard of it. This Markovnikov. What does it say? Negative part will go to that carbon, go to that carbon which has lesser number of hydrogen, which has lesser number of hydrogen. So you can see if you are going to dissociate this, this is the positive part and this is the negative part, and lesser number of hydrogen along double bond, along alkene or double bond. So you have to see along double bond which carbon has lesser number of hydrogen. So you can see this carbon has lesser number of hydrogen. That's why OH will go there. Are you getting my point?
Yes, sir.
Please write. Let me know when you are done with this, then we are gonna do the next. Do the mechanism first.
Yes, sir. Done.
Done. Very good. Now see, I'm going to show you the mechanism. Basically, there will be formation of carbohydrate. So see the mechanism first carefully. Focus here. It has been asked so many times. So basically, there are three steps in this mechanism. So first of all, we are going to see about the first step. So basically, in first step, there will be protonation of alkene to form carbocation by electrophilic attack of H3O positive. Now you can see you have water in which H plus is present. That means it will go and react with this and forms H3O positive, which is known as hydronium ion. So what is protonation of alkene? That means alkene is gonna react with proton, and proton means H plus. So what happens here? There is C double bond C, and this, if you are going to react with this H plus will react with H2O and forms this hydronium. Now you can see this will have positive charge. So it's very easy to understand. Please let me know if you have any doubt. Just first answer me. Positive charge on oxygen is stable or unstable? What do you think? Positive charge on oxygen is stable or not? See, I'm going to give you a trick. More electronegative on more electronegative element, negative charge is stable. Negative charge is stable. That means positive charge on more electronegative element is unstable. Are you getting my point?
Yes, sir.
Both of you. And you know that the most electronegative element is fluorine and then oxygen and then nitrogen. So you can see in terms of electronegativity, oxygen is the second most electronegative element. That means a positive charge on this oxygen is very unstable. So oxygen will try to neutralize itself. And how it gonna neutralize itself? It will take electron from hydrogen. It will take electron from hydrogen and it will form H2O. Now you can see if hydrogen will donate one of its electron to oxygen, it will have positive charge. Yes or no?
Yes, sir.
So at that time, this alkene will attack this hydrogen. And now see what happens. This has two bonds, this has two bonds. And on one of the carbon, hydrogen will come and bond it, and this carbon will have positive charge. Now see what happened here. This is doubly bonded. That means this carbon will take electron of this carbon and it will have negative charge. And this negative charge, that means two electrons, it will give one of electrons to hydrogen and it will make bond like this. Now you can see this carbon since donated one of its electron to this, so it will have positive charge, carbocation. So you can see in the first step there will be formation of carbocation by the protonation of alkene. Are you getting the first step? Is there any doubt in this? Both of you please respond.
No, sir.
So please write it. And then I will go for the next step. Let me know when you are done with this.
Yes, sir. Done.
Very good. Now we are going for the next step. Madhya, are you done with this? Step 2. So what does this say? Basically, there will be nucleophilic attack. Nucleophilic attack of water on carbocation. Nucleophilic attack of water on carbocation. You can see this was the product in the was like this. So it is since present in water. This is electrophile because it has lesser electron. This is nucleophile because I'm I'm an
So your voice is lagging.
am I audible now? I'm an
Yes, sir.
So now you can see there will be nucleophilic attack of water on carbocation. And what happens here? There is H, there is this morning, and there is this morning, and oxygen is now connected with this, and this will have positive charge because oxygen just donated one electron to carbon, so it will have positive charge. Is that clear? Now you can see in a step 3, deprotonation. Just wait, please. Am I audible to both of you? Am I both of you?
No, sir, it's still lagging a lot.
audible? Am I still lagging?
No, sir, now it's fine.
Okay. Now deprotonation to form alcohols. That means we are gonna remove
Proton.
this to hydrogen. What happens in this series, oxygen will take one electron from hydrogen and this will attack here. So you get carbon, this. Am I audible? Am I audible? Am I audible now?
Yes, sir. Now you
I
are
mean, my
clear.
Wi-Fi is not working, so I think it will not be beneficial for both of you because it is lagging again and again. You won't get anything.
Yes, sir.
So
So
can we skip today's class? I will take extra class for this.
okay, sir. Sure.
Wait a minute. Wait a minute.
Okay. Sir.
It's working, so just do for a while. Just complete this.
Okay, sir. Right.
Did you give any test in the last week?
Sir, I think yes, we did a test.
Okay. Madhya, are you listening at all?
Yes, sir, I am.
Okay. Sorry for Are you done with this?
No, sir. I'm doing step 3.
Okay, please do it.
Yes, sir. Done.
Very good. Now see, I'm going to your question. Please let me know the product. Please name the product.
So it will be a CH3, C with H, then yeah, CH4. Sorry, so CH3, so then yes, CH2.
Did you get this,
Yes, sir.
both of you?
Yes, sir.
Thank you. Now, there is another method that is hydroboration. So basically, second method from alkene is by hydroboration oxidation. By hydroboration oxidation, and from here we prepare 1 degree alcohol. We prepare only 1 degree alcohol. If you have given like CH3CH double bond CH2 and hydroboration, that means you know diborane. Diborane, that means BH3 whole twice, or you can write B2H6. B2H6. So can I write BH3 as HBH2 whole twice? Can I write this BH3 as HBH2 whole twice? Yes or no?
Yes, sir.
So whenever you have given like this, and in the second step, there will be basically H2O in the presence of hydrogen peroxide and base OH minus, you just have to do one thing. Just add hydrogen here, anti-Markovnikov, and add OH here. So this is primary alcohol. Yes or no?
Yes, sir.
So by hydroboration oxidation, we prepare 1 degree alcohol in this way. We add, basically we mix this alkene with diborane in the presence of water, hydrogen peroxide and base. Then we get primary alcohol. I will explain the mechanism first, write it, and then I will explain the mechanism. Let me know when you are done with this.
Yes, sir. Done.
Very good. Now see how the reaction took place. It is there is three reaction basically. If you have CH3, CH double bond CH2, and you are going to add HBH2 whole twice. So what happens here? It's very easy. You just need to break this bond and go by anti-Markovnikov. That means this H will go to this and this BH2 will go to this. So you will get CH3, CHH, and then you will get CH2 and BH2. Again, you are going to react this product with alkene that we had taken initially. So I'm going to write this as BH2 and H. Again, what happens? This bond will break and this hydrogen will come here. So I'm going to write this first. See it carefully. Be focused, please. So now this will be CH2, and again you can see this is CH2 and this is BH2, and this BH2 will connect with this. So it will be CH2, and then this CH I am going to write, with which this hydrogen will connect, and then again after this we have CH3. Got it or not? Please watch it carefully and let me know if you got it or not.
Sir, can you explain again the step?
In the first step. Any doubt in the first step? Please let me know if
No
I'm
dot in the
lagging.
first. Yes, sir. You are lagging, and there's no dot in the first.
First step is good. So you can see. Okay, you can see the first step is like this: CH3, CH2, CH2, and this. Oh, wait a minute. This is basically